I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, July 31st.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Please hit the like and subscribe question, and if you have questions, you know 10 other people do too, write it down and we'll be sure and reply. All right, let's get to work. Looking at significant wave heights for the South Pacific Ocean, we see a pretty quiet pattern in play. What is most noticeable is the ice line. Look at it, up to almost 60 south here. That would be about the peak of the southern hemi-winter. Ice covering a large area here. As we started the season, the line was down 65 or maybe even 68 south. So there was a much broader area to support gales getting traction on the ocean surface, their winds, and producing swell. But now with the ice line so far north, the amount of aerial coverage available to support swell development is smaller. And as usual, the swell production machine has gotten quiet. As usual, we start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales when they form, help direct their track. We're looking for a trough, a push in the jet to the north. We don't see it. If anything, here's the southern branch of the jet. It's in what's known as a zonal flow, pushing west to east, right on the ice line there at 60 south. And the northern branch pushing hard to the south. That's actually forming a ridge that does nothing to support gale development. It's the exact opposite. But if we did have a trough, you can almost kind of see something trying to do right there. If the jet were pushing to the north, that would help create a clockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure. And low pressure, if it's strong enough, generates winds. Winds, if they're strong enough, get traction on the ocean surface and generate seas. Seas, as they radiate away from the fetch area to the north, eventually turn into swell. The lesser period elements of the raw seas fade out. The longer period elements continue on. And swell, of course, when it hits your beach, turns into surf. So right now, not a whole lot going on. And we'll just sort of blast through this because that's kind of the theme. We're into Tuesday and Wednesday, August 3rd. Still really nothing happening now. As we get into late Wednesday and early Thursday, you can't really see it, but the strongest winds in the southern branch of the jet push to the north a little bit here. These winds are only 110 knots, maybe 120 knots. But theoretically, there's some very limited support for gale development here Thursday into Friday, and then moving into the far southeast Pacific later on Friday into Saturday. But also notice right behind that, another ridge pushing way south. The ice line, again, somewhere hovering right around here. Any space for a, so there's a trough there, any space for a gale to develop all over Antarctic ice gets zero traction on ice-free waters, and that's just kind of not a particularly good scenario. And now we are out a week out, 6Z Monday, California time. That'd be about 11 o'clock on Sunday, the 7th of August. And still no clear support for gale development. Let's go take a look down at the surface. Surface level pressure, surface level winds, 18Z on Sunday. That's the 11 a.m. California time model update. The models run a little bit behind. But winds, yes, we have a gale, 35, 40, almost 45 knot winds. All those winds pushing due south into Antarctic ice. Does nothing. You have to have winds pushing to the north towards your location. A sufficient speed over sufficient coverage and for a sufficient amount of time to produce meaningful swell. All right, more of the same as we get into Monday. That gale sure looks great if you're a penguin, but for us up north, not a chance. South winds north winds in control, all pushing south. So we get into Tuesday, the 2nd of August. Yes, it's August already. More of the same, just not a whole lot going on. Now on Wednesday, this gale here, earlier versions of the model had this thing building right here southwest of New Zealand with there's 50 knot winds and continuing 40 knot winds, but it was looking a little bit better. This version, for whatever reason, actually on the wave model, on the weather model, the surface level pressure, it still looks like it did earlier this morning. But on the wave models, I'm sort of stealing the show here. Things don't turn out as nice as what the surface wind models suggest it might be. And we're into Saturday now, more north winds pushing south, a little bit of a gale with 40-knot winds off the ice line here on Sunday, but quickly fading out, most energy pushing off to the east. We're 180 hours out. That's a broad, impressive-looking system, all of it over ice. No meaningful swell looks possible. But let's confirm that. Let's go take a look at the wave models. But first, we're going to go back in time. There was a gale. We're back to Sunday. This is late Sunday, the 24th of July. There was a gale. It had like 33-foot seas and then pushed north in the evening and then kind of redeveloped again with 25-foot seas aimed off to the north. Swell from this system has already hit Hawaii. It actually looked better in Hawaii than was expected. So the thought is the same thing will happen in California. That swell just starting to hit this evening in Southern California, and it'll be working its way up in Northern California for Monday, Tuesday, Wednesday, maybe even into Thursday. I suspect the models might be overhyping it a little bit, but there'll be some rideable surf. Anyway, that system fades out, and then we're actually looking back in time. We're last Wednesday into Thursday, the 28th. Another gale developed on the far edge, southeast edge of the Southern California swell window, but as best we can tell, no meaningful swell is expected to result from that either. And things not looking particularly encouraging. Now let's look forward. All right, 18Z Sunday, the 31st of July. The ice line, again, you can see it, maybe 62, 63 south, up to 60 south. In the kind of the southwest Pacific, the main swell production region. That system forecast on Monday, all energy aims south into Antarctica. Another system on Wednesday, 26, 27-foot seas. There's a little tiny area of 30-foot seas, but then it kind of fades out. Certainly some degree of like 14, 15-second period swell could result. And then on Friday, supposedly it's building with, again, a little tiny area of 28-foot seas on Friday night and then fading out. The models had shown seas more like in the 32 to 34-foot range across the whole width of the Pacific. The wind models don't look to have changed all that much. It's kind of interesting how the wave model is not quite handling things like it used to. Certainly since the transition to the GFS model, certainly it didn't handle that mega swell that pushed the code red swell that pushed into Hawaii. Grossly underestimated the seas and the winds there. And we suspect there's some other strange anomalies going on. Anyway, as we get into Sunday, theoretically some 26, 27-foot seas sort of thing. Theoretically, if you believe the model a week out. So maybe some hope, but we're not holding our breath. All right, local winds. But, of course, Hurricane Frank fading off of, we'll say, southwest of Cabo San Lucas. Winds were up to 80 knots. That was on through the day Saturday. Swell has been generated. It is radiating north because Frank is taking a we'll say a northwest, almost north-northwest track. So good energy into Southern California and exposed breaks in Northern California. Nothing huge, but some rideable swell to fill the gap, overlapping with Southern Hemi swell arriving at the same time. Most of the energy, it looks like, is like a late Monday, early Tuesday thing for Southern California and a Tuesday thing for Northern California. And the good news is, well, we'll take a look here as we get into Monday, the local wind situation. You can see literally no wind. This is great for warming water temperatures as well. Finally, a spurt without nuking north winds. La Nina enhanced high pressure in the North Pacific has just been driving this steady northwest flow along the North and Central California coast, causing massive upwelling. Temperatures finally getting pretty decent for a change, but the high being displaced off to the west, driving pretty good trades into the Hawaiian Islands. Windswell there along east-facing shores. As we get into Tuesday, again, a light wind regime, no local windswell for California. Easterly trades for the Hawaiian Islands. Remnants of Frank approaching well off the California coast. As we get into Wednesday, still light winds, high pressure, trades light for the Hawaiian Islands, but maybe some sideband fetch from this working its way into northeasterly facing breaks. So we get into Thursday. Frank pretty much dissipates, we'll say 300 miles or more, 400 miles off of Point Conception, and winds still pretty light for all locations, including Hawaii. As we get into Friday, the 5th of August, now a little bit of northwest fetch forecast as the high tries to ridge just slightly into Oregon, maybe making some minor background wind swell for exposed breaks in north and central California. But even that kind of fades out as we get into Saturday. So really no real wind swell forecast. Light trades for the Hawaiian Islands on Saturday. And as we get into Sunday, again, maybe a little bit more wind northwest at, well, we'll go to the morning, northwest at 10 knots, building some on Sunday to maybe 15 knots at Point Conception. And theoretically, if we can scroll up there, some sort of a tropical system, if you believe the models a week out, approaching the Hawaiian Islands, but the jury is certainly out on whether that will actually occur. All right, let's go take a look long-term what's going on with the Madden Julian Oscillation and the El Nino Southern Oscillation, our long-term weather forecast early predictors. As usual, we start by looking for signs of the active phase of the MJO, the Madden Julian Oscillation. The periodic weather oscillation, there are two phases to it, active and inactive phase. Active phase is on one side of the planet, the inactive phase on the other. They rotate west to east on the equator around the planet. When the active phase moves over the West Pacific, it can dampen trade winds. It also imparts energy to the jet stream. A stronger jet stream fuels gale development both north and south. And also, the reversal of trade winds or the dampening of trade winds when the active phase moves over the West Pacific can take warm water that's there in the West Pacific and start pushing it east under the equator, not on the equator, but under the equator, creating what's known as a Kelvin wave, a ball of warm water, pocket of warm water that traverses the entire Pacific Ocean under the equator, eventually erupting about 3 months later off of Ecuador. Warm water starts boiling up to the surface off of Ecuador. If you have successive active phases of the MJO and they create successive Kelvin waves, then you can get yourself into El Nino, and that's how a lot of times that's a signal that it's starting. So we start by looking at winds. We're looking for slack trade winds in the West Pacific. So this is data from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino. We're looking at the arrows. The longer the arrow, the stronger the wind. So strong east winds in the East Pacific. This is the equator here. Strong east winds over the Central Pacific, and moderate to strong east winds in what's known as the Kelvin wave generation area, the West Pacific, from 135 east out to about 170 west, something like that. When the active phase of the MJO is over this area and it dampens trade winds, that's how you can get Kelvin waves. Now, this is actual 5-day average wind speeds. That's not what we're interested in. We're interested in the difference from normal, okay, for this time of the year, right? Notice the winds are strong out of the east, but this time of year, they're always strong out of the east. It's these subtle, very subtle differences in how the weather is compared to normal for this time of year. So these winds, pretty much normal for this time of year. We don't see really any exaggerated easterly arrows here, just one little arrow there, nor no westerly arrows. Over the Central Pacific, pretty much normal. Over the Kelvin wave generation area, now clearly winds are stronger out of the east. That is a typical sign of either the inactive phase of the MJO or La Nina. So what's the forecast for the next week? All right, this is 850 millibar zonal wind anomalies. This is over the entire planet. It's just fancy words for are the winds stronger out of the east or stronger out of the west than normal. The blues are stronger easterly winds. Think of that as the inactive phase of the MJO or La Nina. The reds and yellows, westerly anomalies, stronger out of the west. Think of that as the active phase of the MJO or El Nino. All right. Now, clearly, the purples and the blues, very strong, running right down the middle of the chart. This is the whole planet. The Pacific starts at about 135 east, so right up through there. The date line, 180 west. And then Ecuador is over about 80 west, somewhere over there. So Kelvin wave generation area is right in here. Easterly anomalies, forecast to be in control, strong till about August 4th. And then they start fading some. Still present, still strong, No westerly anomalies in the Kelvin wave generation area, but certainly easterly winds in control. Let's look further out. Next up, outgoing long wave radiation, another component of the MJO. The MJO, again, acts like a low pressure system, so it can have westerly anomalies associated with it. It can also increase cloud cover. Since it's low pressure, basically low pressure sucks moist air up into the atmosphere. As that warm, moist air hits colder temperatures aloft, it creates clouds and precipitation. So this outgoing long wave radiation is a way to measure the amount of clouds in the atmosphere. If you have less sunlight reflecting off the ocean surface, you have less outgoing long wave radiation and therefore more clouds. All right, so, and the active phase of the MJO. Blues are negative anomalies, less clouds. One can think that roughly as the active phase of the MJO. Yellows, more sunlight reflecting off the ocean surface. High pressure, the inactive phase of the MJO. South America, Central America, Hawaii. EQ, the equator. Australia, New Guinea, the Philippines. Kelvin wave generation area, right here. There's the date line right there. So right in this area. And yes, that's some weak signs of the inactive phase of the MJO, but this is exceedingly weak. Basically a dead neutral pattern today. Go out 5 days, same deal, even more neutral 10 days from now, and more neutral yet again 15 days from now. This is per the statistic model. The dynamic model down here saying, well, maybe a weak tendency for the inactive phase for the next 2 weeks, next 15 days. So the dynamic model a little bit less favorable than the statistic model, but either way, almost a neutral pattern. So we're looking for signs of the active phase of the MJ over the West Pacific, all right? These are what are known as phase diagram charts. Same two models, statistic model here, dynamic model here. They just drill in a little bit deeper and help show us where the active phase is and how strong it is. So the heavy dot is where the active phase is. And let's get ourselves oriented. The MJO moves from west to east, from the Indian Ocean, over the Maritime Continent, to the West Pacific, to the East Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. The dot there, that's where the active phase is, so in the Indian Ocean. But if the dot is inside this circle, then it's exceedingly weak. You really want to see the dot out here somewhere for it to be strong. This line here, the red and the purple line, this is where the active phase has been in July and May. Right now, there it is, the 29th or the 30th of July in the Indian Ocean. And these heavier multi-dotted lines are three different guesses by the statistic model where the active phase will be, but all roughly centered in the Maritime Continent and exceedingly weak. The dynamic model has the active phase trying to move to the West Pacific, crashing back into the Indian Ocean, all exceedingly weak, effectively no active phase at all. So just noodling around, nothing happening, and weakness. So really no MJO influence is forecast, at least for the next 2 weeks for these two models. So we look at the upper level model, all right? This is areas favorable for precipitation. The greens, areas favorable. The reds and yellows, dry air. Dry air, of course, is the inactive phase of the MJO. We're interested in the active phase. That's the one that helps fuel storm development. The greens are what we're looking for. So the 31st of July, oh, and let's get ourselves oriented. South America here, Central America, 0 is the equator. New Guinea there, the Philippines. So Kelvin wave, oh, the date line roughly out here somewhere. So Kelvin wave generation area right there. This shows dry air, inactive phase of the MJO, pretty much moving out in 5 days. Active phase of the MJO starting to move over the West Pacific and make its trek across the Pacific into about, August 30th. So about a 4-week period. That's pretty typical. The MJO takes 4 to 6 weeks to make it across the Pacific. Okay, so it does its thing. So this would be a window for possible storm and swell production, enhanced storm or swell production. Then we get into, August 30th and about the beginning of September, dry air moves into the West Pacific and the inactive phase of the MJO sets up. According to this is a statistic model. So we go out even further. Let's go out a month. This is the CFS model. 850 millibar zonal wind anomalies. Again, the east-west component of the wind. Blues easterly anomalies. Reds westerly anomalies. The reds are the active phase of the MJO. Kelvin wave generation area, well, there's the date line right there. Whole planet on one chart. So from about 135 east to about 170 west, so right in there. You can see the pattern sort of looking back. This is past performance. Lots of easterly anomalies. The dotted contour here is the inactive phase. The solid contour is the active phase. So active phase just wrapped up right now. Pretty much a neutral pattern, but strong easterly anomalies in control of the dateline in the Kelvin wave generation area. Softening of those easterly anomalies forecast a week from now for about a week. Then easterly anomalies again rebuild into August. So this is different than what the upper level model says. What's going on in the upper levels of the model? Supposedly precipitation, but you look down at the surface in the all-important Kelvin wave generation area, and it just looks like easterly anomalies. This is the classic La Nina kind of thing. Still going on. La Nina not quite giving up the ghost. Not yet, but we have hope looking longer term. Let's keep going. So let's look 3 months out, okay, rather than a couple of weeks. And I know we don't believe a model a week out, much less a month, much less 3 months. But I like to be teased, and I like to at least see a glimmer of hope in the future. All right, so this is, again, 850 millibar zonal wind anomalies. The blues are easterly winds. The yellows, westerly winds or westerly anomalies. Now, this is past performance here. The forecast is the top of the chart here. Kelvin wave generation area, well, the date line runs right up the middle here. The far west Kelvin wave generation area, about 135 east, so right there. And you can just kind of see right there, that's the Kelvin wave generation area. We see easterly anomalies building into the first 2 weeks of September. And then after that, according to this model, and this is probably the only one of the better models, easterly anomalies take a hit. They try to regroup. They take another hit. And westerly anomalies start building, not in the Kelvin wave generation area, because it starts at 135 east, so right about there. But westerly anomalies making forays into the Pacific to the date line. What's even more interesting, even if it's not westerly anomalies, just a significant reduction in the easterly anomalies might be enough if it's sustained over time, and one could assume that's like the active phase of the MJO there and another active phase of the MJO there, that perhaps maybe this is the beginning of the end of La Nina. So let's overlay the MJO. All right, solid contours of the active phase of the MJO. We're going back in time here. You can see that for yourself. Only in the Kelvin wave generation area does it matter. So from about here to about here. In a dotted contour, inactive phase of the MJO. Weak active phase tries to make an entrance in the Kelvin wave generation area in the mid to late August timeframe. Doesn't do it. Some sort of a resurgence of the inactive phase of the MJO sets up into early September. But after that, the active phase of the MJO sets up. You can see dragging its westerly anomalies to almost the date line and neutral anomalies even east of there. It fades. Inactive phase tries to set up, but still much weakness in the easterly anomalies. Now, this model has consistently teased us with promises of goodness, and then when you really get to, in this case, the October timeframe, something different sets up. But some of the other long-term models, not talking specifically this outcome, but they're all sort of suggesting perhaps the end of La Nina as we get into fall. In fact, let's overlay the low-pass filter here. In fact, we can take off this and this, and you just see the high and low pressure bias in the Pacific. Now, the dotted contour is the high pressure bias, tendency towards high pressure. We see that supposedly holding for the next 3 months over. Mainly the core of it is somewhere out here. So what would that be? About 170, maybe 160 west. Okay, so that's not over the Kelvin wave generation area. Pieces of it are. And the low pressure bias, the El Nino tendency, pushing to, well, what's that, about 150, something like that, midway through the Kelvin wave generation area. Now we're going to overlay the 850 millibar zonal wind anomalies, and you can kind of see it better here. You see The low pressure bias, not really changing a whole lot. In fact, it's gone backwards compared to where it was back in May, but you get the sense that maybe it wants to start pushing west a little bit, and that maybe it's just strong enough to send off pulses of energy from it to sort of tear into what's left of La Nina. And of course, when La Nina, when the core of it makes it over into the East Pacific, that doesn't do a whole lot for it. I mean, the main part where you're feeding all your energy is over the maritime continent and into the far West Pacific. That's where the main activity comes that's going to fuel the jet stream, that's going to fuel storm development, that's going to fuel Kelvin wave development and set up a different kind of pattern for the Pacific long term. And that's the suggestion here. So that gets us to the El Nino, La Nina portion of the discussion. We're looking for signs of a transition. Clearly, we're in La Nina today. We have been for 2+ years. We're hoping that it fades as we get into this winter. All right, so let's look at subsurface water temperatures. We're interested in Kelvin waves because that is kind of, and the balance of where warm and cold water is in the Pacific. La Nina typically is dominated by cold water off of Chile and Peru and working its way over the equator, all right? So we're looking at subsurface water temperatures here, down 400 or 500 meters. Really, it's only about 150 to 200 meters that matters. So 450 to maybe 600 feet down in the ocean. This is the West Pacific here. This is the East Pacific here. These little X's and lines here, this is the anchor lines on the TAAO buoy array, a series of buoys strung across the equator used for monitoring El Nino, but they also monitor for Kelvin waves. These little sensors read data, maybe hourly, I'm not quite sure how often, from the sensors are strung down the anchor lines on the buoys. They read data, water temperature. It's relayed to a central processing facility, use a model to fill in the gaps, and lo and behold, you get a sense of where the warm and cold water is. The 29-degree isotherm, 29 degrees centigrade, that's warm water, about where it was last week at about 168 east. The 28-degree isotherm, right where it was last week, no change. The 26-degree isotherm, now here's sort of the not-so-good news. It was over at 140, it was at 130, at one point I think it was at 120. It's backtracking now to 155 west. The 24-degree isotherm, still holding the whole way across the Pacific, but getting shallower, suggesting that cold water is maybe building somewhere in this area. But it's not, again, the actual temperatures. It is the anomalies, differences from normal for this time of year. We see warm water in the deep South Pacific. Almost looks like a Kelvin wave, but it's not budging at all. Last week it was at, well, right here, 170. That's right about there, 170 west. Maybe moved a degree or two, but not much. And instead, there's this cool pool building here, 3 degrees centigrade below normal. It's actually expanded in coverage some from last week. The remnants of what was a Kelvin wave gurgling to the surface. So you can see warm water goes down. If this cool pool wouldn't here, it would move the whole way across the Pacific, gurgle up in the East Pacific. The last little bits of that Kelvin wave are gurgling to the surface as we speak, or erupting to the surface, then getting caught by the trades and dragged across the equatorial Pacific. Now there's another model here, a little bit higher resolution, showing the extent of the warm water in the West Pacific. The water's temperatures look much deeper. In fact, 1, 2, 3, 4, 5, almost 6 contours. 1, 2, 3, 4, 5. So let's say 4 degrees above normal. The other model said 2 degrees. So much warmer in the West Pacific. There's your cool pool building, and there's the last little remnants of what was the Kelvin wave fading out in the far East Pacific. Sea surface height data from July 27th. Okay, and this only updates every 5 days. These are not temperatures. These are the height of the ocean. How many centimeters above or below normal? Yeah, you take satellite data, you strip out the wind waves, strip out the swell, the waves, even the tides, and you can get incredibly sensitive measurements to within 5 centimeters, which isn't very much, on whether the sphere of the ocean is higher than lower than normal. If you have cold water at depth, cold water contracts, you get a divot on the ocean surface. Likewise, if you have warm water at depth, it expands, displaces water above it up higher. So let's get oriented. Chile, Peru, that's the equator right there. Central America, the dateline right there, the equator there. We're only interested in 5 degrees north and south of the equator. That's what Kelvin waves start here, and you see all these positive anomalies here. That's warm water. The active phase of the MJO with its westerly anomalies. Yeah, I'm actually literally doing a low pressure circulation in the southern hemisphere. It'd be the exact opposite direction. Create westerly anomalies that can tap into this warm water, push it east, and it moves across the equator and then erupts off of Ecuador. But we have positive anomalies here, but we have negative anomalies here. That means cold water at depth is here. That's blocking any Kelvin wave development. It would take one heck of an active phase of the MJO to punch a hole through this thing. So looks like an upwelling cold phase is starting now, and cooler waters the whole way over to Galapagos and Ecuador for now. So nothing really indicative of a warming phase suggested. All right, so this visualizes a little bit better, puts things in historical perspective. West Pacific here, East Pacific here, upper ocean heat anomalies. Just is the water warmer or normal than colder for this time of the year? You can see back in December, we had an active phase of the MJO that took the warm water here in the West Pacific, pushed it across the entire equatorial Pacific in the form of a Kelvin wave that just barely made it to Ecuador. Then we had an upwelling phase. This was back in March and April. Cold water dominating. Another Kelvin wave, actually it was almost two pushes from 2 active phases of the MJO, made it to about 100 west, not even to Ecuador. The last little bits of that Kelvin wave are fading as we speak right now. And here's the developing cool pool. Looks very similar to this one. Hopefully it'll last only, well, this lasted, what do we say, mid-February to March to April for about 3 months. So we're in July. Actually, this looks hopefully not like this series up here. This was last year in August, September. I mean, full resurgence of La Nina. The suspicion here, this is only going to last about as long as this one, and that might be the end of La Nina. So we've talked subsurface temperatures. Now we look at surface temperatures as anomalies, differences from normal for this time of year. South America, Chile, Peru, Ecuador, the Galapagos right there. Central America, Hawaii right there. The equator right there. You can see warmer than normal temperatures on the equator going out to 140 west. This is the result of that Kelvin wave upwelling, trades blowing out of the east here on the equator, dragging that warm water off to the west. Colder than normal temperatures here. This is a clear La Nina signal. All this cold water off of Peru mainly, dragging itself the whole way out to the dateline and beyond. But this warm water wasn't there before. It's only been there a month or so. Of course, courtesy of that Kelvin wave we talked about earlier. We suspect this will fade over time and temperatures over the greater Pacific. The official El Nino monitoring region, 120 west, so on the equator, 5 degrees north and south. So from here out to 170, so right here. You can see there's some warm water in the official, they call it the Nino 3.4 region, and some cold water. So unclear of where the balance is, though we suspect it's probably still colder than normal. This is pretty intense cold water. But the intensity of cold water in general, certainly down here, not anywhere near as bad as it was months ago and over the past 2 years, suggesting maybe La Nina is losing its grip. Sea surface temperature trend just for the past 7 days, and all we care about is right here on the equator, this area right here. You see a mix of the reds and yellows, warming temperatures, the blues, cooling waters. So the analysis here is likely the last of the Kelvin wave is creating the warmer than normal temperatures, and the weakening of water temperatures as the Kelvin wave and its associated warmth starts to fade is reflected by the blues. So sort of a mixed bag as of right now. Neither getting warmer nor getting colder, just sort of holding status quo for the moment. And then the backed off view right here. Again, you can see there's the Galapagos. Warmer than normal temperatures right here, colder than normal temperatures. Kelvin wave, the official El Nino 3.4 monitoring region right in there, 120 out to 170. So a mixture of warm and cold, though the colds, again, look stronger. And just for your reference, the Nino 1.2 region, we'll get into this in a minute, is right here in this area off of northern Peru and Ecuador. Sea surface temperature trend in the Nino 1.2 region, that area we just talked about. Today, temperatures 887 thousandths of a degree below normal. The threshold for being out of La Nina or being into La Nina is half a degree below normal, so still clearly in La Nina territory. In El Nino, you got to be a half a degree above normal, nowhere near that. But this is kind of a noisy area. It changes radically, especially with the arrival of Kelvin waves. And then it's the Nino 3.4 area that really matters. We had temps up to almost 0.2 of a degree below normal, and we were, well, right along here is the indicator for the moving into El Nino, not neutral or La Nina. Today's value, 558 thousandths of a degree below normal, so just back dipping into La Nina territory. And the expectation is that's going to continue for a bit. We had, what, let's see, we'll say 1, 2, 3, 4, almost 5 weeks of out of La Nina territory temperatures, but now we're falling back into it. This is not unexpected. This is exactly what the model suggested. All right, so let's go take a look up in the atmosphere. The atmosphere interacts with the ocean, right? As the ocean gets cool, it produces high pressure above it because you don't get evaporation. You don't get lifting air, right? Warm water creates evaporation. That lifts the air, that lowers surface pressure. But if you have colder than normal water at the ocean surface, that creates a sinking pattern and pressure goes up. All right, so looking over the entirety of the Pacific, we're looking, this is the Southern Oscillation Index, basically the difference in pressure between Tahiti and Darwin, Australia. Tahiti, of course, in the Pacific, Darwin roughly in the Indian Ocean. When pressure is lower in Tahiti, the index goes negative, all right? And that's what we want to see. That typically happens when the active phase of the MJO moves over the West Pacific. Tahiti is in the central to West Pacific. And also when you get El Nino going on, which is basically just a continuous long-running active phase of the MJO, the index goes negative. Today's value, though, plus 28.87, and it's up a bit. We were down at, well, we got down to 0.6 here in mid-July. This was typically the active phase of the MJO. You notice we had higher values. It started fading. Now it's rising again. But this again is this is an everyday update. So you do the 30-day average. The value today plus 7.23. You see, we were actually much, much higher. We were at 17. And then we've been steadily dropping for a month. Again, likely driven by the active phase of the MJO. The 90-day average, this would be the El Nino La Nina indicator. Today at positive 1408, still clearly in La Nina territory. Compared to a month ago at 18.40, moving in the right direction, but that also could be just attributed to the active phase of the MJO. No clear-cut sign yet of a trend towards El Nino or even neutral. Still pretty solidly, but not as solidly as we were in La Nina territory, suggesting maybe La Nina is losing some of its bite. The 30-day SOI graphed out. Now this sort of paints the picture a little bit better. The downward spikes are the active phase of the MJO. The upward spikes are the inactive phase. You can clearly see when the inactive phases are stronger, the index goes positive into La Nina territory. 0 is neutral, right? Okay. Clearly, in January 2020, we were in neutral to weak El Nino territory. And since July of 2020, through 21 into 22, 2 years running, we've been in a period where the inactive phase of the MJO has dominated. You can just literally draw a line through this and it's been upward. But now we're getting into this, notice, a falling trend. We saw it in the previous data. Now we think that probably we're going to be in some sort of a neutral territory. It'll be interesting to see what happens here, whether this starts rising again. It almost looks like it's trying to make a bump upward here, or whether it just sort of hovers somewhere in this range. Still unknown. I haven't seen a model that predicts the SOI. That'd be an interesting thing. But instead, we can look at sea surface temperature predictions and get the same net effect. Sea surface temperature forecast for the Nino 3.4 region, the official El Nino monitoring region from the CFS model version 2. All right, so July, this is mid-July. We're in late July. This model shows falling temperatures. It's actually downgraded, I think, 3 days ago. And for weeks before that, it had temperatures bottoming out at about 0.8 degrees below normal. Now it's suggesting maybe -1 degree or even 1.1 degrees into November. But after November, a steady upward trend. This suggests the fading of La Nina. Now, this is the raw data. There's some known issues with that. The PDF corrected version right here, PDF corrected, is probably the better estimate. Temperatures, so falling here to, say, maybe 0.8 of a degree below normal, which isn't too bad. Hovering, maybe dipping a little, not even to 1 degree below normal in November. And then from there, steadily upward over the, right here, over the La Nina threshold as we get into November, and then heading neutral and a little bit above neutral as we get into the core of winter. That's exactly what we want to see. And if the sea surface temperatures are rebounding to neutral as we're into, well, this would be really March, something like that. But if they're rebounding even here, that means something's driving that temperature change, and it would be happening earlier than November. So the suspicion is that whatever is happening cold-wise in that cold water ball, it'll go for, well, let's see, we'll say August, September, and October, and then it fades, and after that, sea surface temperatures will start warming. The atmosphere is already changing as we get theoretically into October, and after that, it's smooth sailing. Right, so we'll see if we can do this here. This is the sea surface temperature projection for the Pacific, kind of small here, but you get this is a projection. We saw the actual temperatures. We know there's warmer than normal temperatures right here. Now this is for August, so those warmer temperatures fading, the extent of the cooler temperatures. Still clearly a La Nina signal. We'll jump 2 months. We'll go into October, and again, the deep, deep cold temperatures here are gone. Let's go back and look at that again. See the deep cold temperatures there? And then we go here, they're fading. Now let's go out another 2 months. We'll go into, here we are in December. The cold temperatures all but gone, just the faintest little bits, half degree, 3/4 of a degree anomalies fading. And again, South America there, Central America, the Nino 3.4 region, right out in here, the Nino 1.2 region. This is what drives the global planet circulation, temperatures right in this area. And then we go out yet 1 more month. We're into January, full neutral pattern. Now to get that to happen, the atmosphere would have to have significantly changed something to get to dissipate all that cold water. In fact, even we're thinking in September to October, the atmospheric change must be starting, because when you get to November already, there's a significant dissipation of cold water. So for right now, small swell working its way into California. Most of the swell has already faded in Hawaii, so California to be the focus for 3 or 4 days. No huge swell, but maybe something rideable. Hurricane swell from Frank, also in the mix, especially in Southern California, not so much for Northern California, just given the extreme south angle, like, 175 to even 170 degrees in Northern California and about 175 degrees down in Southern California. So swell for the next week. Looking longer term, well, not a whole lot going on. MJO, not so much a factor. East anomalies setting up. But looking even longer term beyond that, the models are clearly suggesting the fading of La Nina as we get into fall. And by the time we're into the beginning of winter, December 21st, we're actually rolling this up a little bit, maybe even late fall, Thanksgiving, something like that. The atmosphere should start shifting because the water temperatures in the models, the temperatures are starting to rise. That suggests the end of La Nina, which means that as we get into this winter, we might eke out a normal swell pattern. With luck, maybe. And maybe even precipitation. And maybe even snow. Of course, that's maybe also reaching a little bit much, but either way, it looks like we're into a better pattern, and the coming winter will not be a washout. It will not be a bust. Certainly California needs water. We'll take it any way we can get it, and the more the merrier. All right, so that's it for this week. If you enjoyed the video, give us a thumbs up. Like and subscribe if you haven't. You get automatic notifications when we post the video. If you have questions, be sure and write them down. We'll answer them. And that's it. We will do this again next week, same time, same channel. Thanks for watching.